Good morning, sports campers. Okay, what are we doing today? We're doing Advent of Code 2020, day 19. Just bring my mic down. There we go. And right, let's get started. I guess we can close all these tabs from yesterday. Yesterday was, oh yeah, I gotta turn off notifications. It's not there anymore, it's here. Do not disturb. There you go. All right. Let's get rolling on day 19. Holy crap. So I've heard that today is extremely challenging. So maybe what we'll end up doing is we'll end up doing the part 1, part 2 thing again, where at some point I have to take my dog out, even though it's raining. We still got to go out. So maybe at some point today we'll break and come back and do a part 2. I don't know. Let's find out. There's no shame in that. There's no shame in being stumped. So, all right, monster messages. You land in an airport surrounded by dense forest. As you walk to your high-speed train, the elves at the Mythical Information Bureau contact you again. They think your satellite has collected an image of a sea monster. Well, that's neat. Unfortunately, the connection to the satellite is having problems, and many of the messages sent back from the satellite have now been corrupted. Of course they have. Okay. They sent you a list of the rules valid messages should obey, and a list of received messages they've collected so far. The rules for valid messages, the top part of the puzzle input, are numbered and build upon each other. For example, 0, 1, 2, 1A. Okay, so some rules, like 3B, simply match a single character, in this case B. The remaining rules list the sub-rules that must be followed. What? Okay. For example, the rule 0, 1, 2 means that to match rule 0, the text being checked must match rule 1, and the text after the part that matched rule 1 must then match rule 2. That's interesting. The part after. So it's like these are individual matches? So this isn't like it must match 1 and 2. It must match 1 and followed by 2. Okay. And then 2. Okay. So in this case, it must match 1 followed by 2. So it must be an A followed by an A or an A and a B, or a B and an A. Sounds like this looks like regex. This is a weird regex. One of the rules have multiple lists of sub-rules separated by a pipe. Yeah, at least one list of sub-rules must match. Can you do variables in regex? Maybe not. Maybe I have to like compile rules. The ones that match might be different each time the rule is encountered. It means that at least one list of sub-rules must match. Some of the rules have multiple lists of sub-rules separated by a pipe. Oh, yeah, okay. So that's just the regex like this or that. Okay. To match rule 2, yeah, okay. Fortunately, there are no loops in the rules. Thank God. So the list of possible matches will be finite. Since rule 1 matches A and rule 3 matches B, rule 2 matches either AB or BA. Yeah. Therefore, rule 0 matches A, AB, or ABA. Yeah. Okay. Here's a more interesting example. So 4 and 5, 4 is A, 1 is 2, 3, 3, 2, and 2, 3 is 4, 4. Oh, Jesus. Okay, yeah. The received, I can see why this is going to be challenging. So we're going to have to construct a series of regexes. So does it have to, no, it doesn't have to match all the rules, right? It just has to match a rule. I guess we'll find out later. All right, because rule 4 matches A and rule 5 matches B, rule 2 matches 2 letters that are the same, AA or BB, and rule 3 matches 2 letters that are different, AB or BA. Okay. Since rule 1 matches rules 2 and 3, once each in either order, it must match 2 pairs of letters, 1 pair with matching letters and 1 pair with different letters. Okay, let's go over this again. This looks complicated. Since rule 1 matches rules 2 and 3, or 3 and 2, it must match 2 pairs, so 4s and 5s, or 4s, 5s, 4, 5, 5, 4, or 5s, 4s, and then 4, 5, 5, 4. Okay, yeah. So this is okay. So we need to evaluate all of the ones with variables. Okay. Yeah. The received messages, the bottom part of your puzzle input, need to be checked against the rules so you can determine which are valid and which are corrupted, including the rules and the messages together. This might look like, yeah, okay, your goal is to determine the number of messages that completely match rule 0. Oops. In the above example, they match, they do not, producing the answer to the number of messages that completely match. Okay. So I don't know. So we could generate, we could generate permutations, or, could we use a regex? We might be able to use a regex. This looks like, it feels like a regex. Let's give it a shot. All right, nope, not new file. Nope, new folder. Day 19, holy crap, okay. We've done so much of this. All right, I'm cautiously optimistic about today, about part 1 anyway. I have a feeling part 2 is where we just get demolished. So I was mentioning there's people out there who solve these in minutes, in a couple of minutes, and that's impressive. I'm nothing but impressed by people who solve these in a couple of minutes. That said, that's it's a really specific life skill, and I think you should be proud of having a skill like that. But it's not the only skill in life. Being able to solve these fast, when you're programming in a real product environment, the number of times a year that you need to solve a problem like this is you can probably count them on one hand. I would say great skills to brush up on in terms of programming would be user empathy. That's a big one. Understanding the bigger picture of what is the problem, what is the root of the problem that you're solving, and a lot of the rest just comes down to experience of oh, I've done this before. I know that we probably should avoid this because it broke last time. Those are the 3 pillars of programming. Being clever is probably the least important, honestly. I think being empathetic to your user or to your customer, whoever you're solving the problem for, is a huge one. And as is being persistent, being able to continually hack away at something over years is really important. Yeah, so it's not exciting. It's all those scenes where people are hacking in movies and they're just furiously typing. That's cool. But I think real hackers spend a lot of late nights just probably stereotypically drinking Fanta and being why is A 0? Which is cool. All right, so what are we doing here? So we got our defs, we got our tests, we got our section where we're gonna run the thing. So let's pull in our usual suspects. We're gonna bring in log from console. I always destructure this because I mistype console so often. It's shameful. I've been programming since I was like in my teens. Now I'm in my 40s now, so 25 plus years. Still can't type to save a damn. Make typos all the time. Maybe one day I'll learn to type. Okay, so let's grab. So this is going to be. We're going to want some input. So this looks like this is the input that they provided us with. So let's make this our input. This is going to simulate what we actually get. So we're going to have two sections. We got a rules section and then we got a data section. So we're going to need to parse input. And let's write that. Okay. Parse input equals, so we got a wall of text. And whoops, that wall of text. So we're gonna have rules and data equals text dot split. Two new lines. Okay, so we're gonna have rules block and a data block. I guess we could further split those into lines. So we are gonna need, for the rules, we are gonna need these headers. I mean, we can parse a rule later on. I think maybe what we can do is we can, I don't know if we want to do this all in parse input, but we might. Ultimately, I think what I'm going to try first, and maybe this is why people go down this multi-hour rabbit hole that I've read about, is that they think this is a regex, and I think this is a regex, so maybe this is the beginning of my descent into madness. I'm going to try and construct a regex out of this, and to do that, I'm going to have to like recursively sub in all of these things. Each one of these is going to, I'm just going to have to find a string and sub it with numbers, and then those numbers are going to be strings of other numbers, and then those eventually I'm just going to have to keep subbing until it's all A's and B's and there's no numbers anymore. That's my goal. Okay, so I've got rules and data. So the data is going to be easy. The data is just going to be data dot split on new line. So then this is going to give us 1, 2, 3. It's like 5 lines. And then, okay, so we got that. And at the end, we're going to rules data. We're going to pass back rules and data. What I said earlier about not knowing how to type, I hope you're getting a good, I see, it's like the prophecy was real. You really can't type. Okay. So input, what are we going to do here? First of all, we need to do the same thing. We need to split the input, or the rules. Rules equals rules. Split that, and then for each rule, I think what it makes sense to me to do would be to parse the rules with regex. To grab the number and grab these numbers. In fact, these numbers are going to be, they're going to be strings. So maybe we don't need to parse anything as a number, because why do we care? I mean, what is a number? What is a number? A number is just a symbol. And I don't care if that number is expressed as a string, because we're just trying to match. We're just trying to match a 3 to a 3. So if it's a string 3, then so be it. So let's make an object. Let's make a rules object. I'm overwriting rules. That's probably a bad idea. So let's, okay, cool. And let's split on that. And then let's map on rule So basically what I want to do is I want to populate this object with key value. And then value, I'm gonna remove the spaces from value. So we wanna parse this. So I could just grab the first character. I guess what we should do is we should check to see if there's any double digits, because if there's double digits in the actual input, then this could get messy. And there are double, triple digits. Okay, there's lots of rules. Many rules. So we're not doing this as a string sub. We're gonna actually just regex this. Dot match. Let's just test this down here. All right. So we're gonna match this against. So D plus. Okay, we want to capture that. Then we're gonna have a space, and then we're gonna have a digit plus, I guess, because they're multi-digit things, followed by an optional space, and then this is sort of like a non-capturing group. What can we have in here? What we just, you know what? All we want is non-spaces. That's what we want. So we want it followed by not space plus. We want to find all of the characters after this, and we want to actually, you know what? I'm overthinking this already. We just want to get the rest of it, and then what we can do is we can just split on space and join, or we can remove spaces after that. Okay, so this is going to be 1 and 2. So let's see what we get when we run that. Of course, we should log it. Log. Okay, so 0 and 415, so that's fine. And let's try a more complicated example like this one. So it's more complicated is very loosely defined here. Okay, 2, 4, 4, 5, 5, beautiful. Okay, so we're gonna have all right. So there's not. This is one of those cases where we could define this once elsewhere, and I guess we could. I feel pretty ambivalent about it because, oops, dot match. Because really we're only parsing like dozens of rules. It's going to be pretty fast, but you know what? May as well. So rule dot match rule pat. So that is going to give us some crap we don't care about, which is the entire match string. Then it's going to give us the name of the rule and then the body of the rule. So name, body. Yeah, I don't know how I feel about spaces at the beginning and the end of these. I'm gonna go without spaces at the beginning and the end when I'm just doing assignments. Maybe that's a bad idea. Maybe I should be consistent. I feel like if it helps the readability, does it? I don't know. Anyway, let's be consistent. All right, so what we got? We got the name and the body. So I'm going to, we need to parse the body further, and then we will say object name equals body. And I guess all we're doing to parse the body is we're going to body dot replace space with nothing, and that's going to be global. Cool. So let's try this down here. So we'll say name body equals, and then we'll say body log body replace. Let's see what happens. Okay, 4455. Beautiful. Yeah, I think that's what we want. Let's take a look at the actual input. Yeah, because there's no spaces in the input. Okay. We'd probably be fine, maybe, with spaces in the regex, but I'm not going to take that chance. Okay, cool. So we got these rules, and we've got. So we're going to have this object out. So this rules. These should be rule defs. And then this can be rules. Rules. And then rule def. That makes me feel better. And then we're gonna return rules and data. All right, let's see what we get out of this. Parse input. Boop. I already got that there. So, bam, cannot read property split of undefined on line 71. Data. Oh, whoops. I'm not doing a regex match here. Okay. Oh, we should log this. All right. So we've got our list of rules here. And then, oh, you know what? Because they have 2-digit rules, like this could be rule 4 and 5 or 45. I guess that's why they have the spaces. So let's leave that off for now. And then we're gonna have to, so the next thing we're gonna have to do is we're going to have to, oh, that's not great. These quote marks. So you know what, let's replace quote mark with nothing. Okay. Okay. I wonder if there's, let's look at the input that they give us and see if there's any weird rules with multiple letters. No, that's fine. Is that the only letter? What? Is it all just A's? Is it all just groups of A's? It's gotta be more letters in here. Oh no, there's a B. Okay, I found a B. So it's all A's and B's. Okay. Cool. Okay, so I'm removing these quotes because we're not going to be splitting on these. What we're going to be doing is we're going to be looking for any decimal, and we're going to be replacing it with its rule. So as we go through, what we're going to do. Okay, so let's maybe we can do this now. Say for rule in rules, or for name def in rules. So what we want to do is we want to go through the first one. We want to find this 4, and we want to replace it with A. And then we want to find this 1 and replace it with this, and then we want to find this 5 and replace it with that, and then yeah, okay. I guess what we could do is we could go through just the 4s and 5s, or we could just go in a loop. We could just keep doing it until. Yeah, what do we want to do? I guess the fewer substitutions we do, the better. So if we replace these 2 rules first, then when we subbed in this one and this one, we'd be done. If we did it the other way, we theoretically have to reevaluate this rule several times. What we could do is we could cache the result. We could recursively solve this, and as we needed to sub in 4 or 1, then we'd have to solve this, and we could cache the output of this, which would solve these, and cache the output of them. And then when we came to solve these, we'd already have the cached output. That's similar to what we were doing in a previous day. I forget which day. Parse input. I feel like this is getting too complicated for parse input. Like we're actually starting to do a lot of work for this. So let's let's convert the rules now. Okay. Okay, so we'll have process rules. And that's going to take rules as an array, or defs as a rule as an array. Okay, so and then we can do what we're going to do here. So we're going to have a cache. Whoops. Okay, so this is going to be our result cache when we're caching, I don't know how much of a problem this is going to be, honestly. But this is a pretty simple pattern to implement, so I feel like, okay. So we are going to want to parse the rules for key val of defs. So let's make a rules array, and the rules array, or maybe a rules object for now. Okay, for key val of defs. So what we're gonna have is we're gonna have this 0. We're gonna have a key in the val. So we're gonna need to parse the val into we're gonna get a list of digits that we need. And for each one of those digits, we're gonna need to resolve those to a value. So we're gonna need, so the match, and we're going to need digits. Right, we're doing this today. Okay, equals val dot well, should we even get digits, or should we just, I mean, we could just split them on space, and then go through to figure out if parse int is in 0 to 9, or parse float is in 0 to 9. And we don't want to substitute these. We don't want to substitute any A's or B's that we have. Yeah, okay, so let's do that. Okay, so let's just do val dot split on a space. So that's going to be for val in, or not val, for char in char. For symbol in that. So we're going to have a symbol 4, a symbol 1, a symbol 5. We're going to have a symbol pipe, symbol A. Okay. So for symbol and index. In that, what we're going to do is we are going to want to resolve the rule. And this is really like, this is the work that we're doing here, is going to be resolving the rule. And we're going to need to have, we're going to need to pass our cache in. So process rules. This is a terrible name for a function. Okay, so we're going to have the existing rules, or the existing defs, but these, wait a second, these defs aren't an array, they're an object. Okay, yeah, val of defs. Okay, so we're gonna pass in all our defs. We're gonna pass in our cache because we're gonna need to access that, and then we're gonna need to pass in the current def. And then this def is going to be val. So process rule val. And then this is going to be defs cache. I don't know if this cache thing is even worth it. Okay, so this becomes def. I guess this can be key def. Okay, cool. So we got that. let's just log what we're doing here, symbol index, or let's log IDX symbol and just see if this is happening. Process rules. So this is going to be rules and data, or yeah, rules, data. Fine. We're doing the space thing today. Equals parse input, and then we'll come process rules. I guess we don't need to log it. Okay, so log, so for symbol index in, so let's log the def as well. Okay, so we got 4 and 5 saying 0, 4, 1, 5, 2, 3, 3, 2, 2, 3, 3, 2. Okay, so I mean we're doing okay so far, and we should probably, so that's logging the index and the symbol. Oh, should we also have the current def name? I don't think we actually need the current def name, do we? No, because they're not recursive. We don't care. Okay, so it should, I guess it'll be the responsibility of the outer loop to write to the cache. This just provides it to the cache. Or what we can do is we could pass the key in as well, and we could return the cache. We could write the cache and return the cache from the process rule function. In which case the process rule function really does everything. So if we pass the cache in and we write to the cache here, then say this first one, 415, solves this one, which is 1, which it will, then on the subsequent thing, this cache would be available. I guess the cache would be available. Yeah, because process rules is going to have to write to the cache, because process rules can be doing this as well. So I guess process rule is really just going to do everything. So we're going to need the key. Is what it is basically what I'm saying. Key def, and this can be key def. Okay, so cache key. So we'll return cache key if cache key. Otherwise, what we'll do is we'll need to sub it in, and we'll sub in the value for process rule, key, and def. And I guess we don't need to pass in def because we can look it up. We've got the defs. So okay, so we're gonna process the rule for key. I guess this can be processed rule for key, but I don't think we actually need to do that. So it's either going to be, so defs key. All right. So for, I guess we can just say def equals. Okay, so for symbol and index in def split. So what we're really going to do is we're going to map over this definition, and we're going to substitute def equals. Okay, I guess we can just do that. Split and then map. I feel like I'm overthinking this. Map symbol. Whoops. So this is going to give us a list of symbols, and we're going to, so if symbol, so if parse float, if it's a number, let's take a look and see what we get from parse float. Down here, let's turn this off. Let's parse float 1, 2, 3. I guess we should log it. What's it? If parse float symbol. There you go. So 1, 2, 3. What about part 1A3? 1. This gives us a. So what are the things that we're going to be parsing? We're going to be parsing numbers or pipes. Pipes give us nan. Space gives us nan. A gives us nan. B gives us nan. Okay, cool. So lol if parse float. No. 1. Yep. So nan is falsy. Good. Always have to check those things. So if parse float sim, if it looks like a number, what we're going to do is we're going to return, or I guess we'll return sim unless parse float sim. Otherwise, what we're going to do is we're going to recursively call process rule with def's cache key. And that's going to give us the value of that. So we return the symbol unless we parse float it. And if we do parse float it, then we have to process it that way. So wait a second, I'm totally missing a step here, which is where we actually go and look the thing up in the defs. So let's look at our example. So for what we want to do is it's not going to parse as a, or it is going to parse as a float. And so if it does parse as a float, we process the rule and that's going to sub in 4 and then that's going to return the symbol because it doesn't parse as a float. So yeah, maybe that will work. Okay, so we're gonna map that. So that's going to be our def. And then what we can do is we can say cache key equals def. And then that will update our cache and return the value. So let's try that. Process. So this is going to be process rules. And really this is just what we're doing. Okay, I think. So we initialize the cache here and then we start passing it in. Okay, so let's try that. Process rules. Yeah. Okay, bam, exploded. Cannot read property split undefined. On line 90. Equals, let's try that. Still not happy about that. Split of undefined def's key. So what is defs? Let's try this. Is it still angry about split of undefined? Yeah. Okay. So what's defs? Log defs. Okay, and then we get an empty one. Process rule. Oh. I just copied these down. That's why. Okay. That was def's key split. Okay. Now what are you angry about? Oh, you're long angry. Okay. Range error. Maximum call stack exceeded. Okay. So return sim unless parse float sim. Process rules. Def's cache key. And then cache key equals def. So let's log def here and see what Big Angry gives us. Maximum call stack exceeded. So we're returning cache key if cache key is present. I guess we can just say if cache key. Yeah, and it keeps looping on line 91, which is map. So we're splitting on def's key. Okay. Def's cache key, or key, and then we don't actually care about that of defs. So these are rules. So let's log rule defs, and then key defs key. This should happen once at the top. Rule is not defined. Oh yeah, log. That was key that I wanted there. Okay, key defs. Okay, so it does this a bunch of times, and okay, so we're logging the key, which is literal 0. Oh, this is the key of the rule we're looking for. Okay, and do we have a cache for that key already? No, we don't. So we get def's key, which is this 415, and then let's log sim in here. Make sure that we're okay. Sim is 4. And then, so we go into here, and we should be calling, you know what, it's not key that we're calling it with, it's sim that we want to call it with. Okay, so there we go. Whoops. Hey, I can get rid of that log line. Okay, so we're still logging this guy. Okay, so then we're cache key def, and then process rule, we should be returning, whoops. That whole thing is an array. So process rules, and are we? Oh, we're not logging them. Well, that's not readable. Let's JSON.stringify process stringify process rules. Well, damn. I guess what we should be doing is joining these. Okay, so these are our process rules. We got AA or B. Oh, you know what we should do is we should wrap these in a capture group like that. Def. That's totally not what I meant. Maybe we don't. We do need to group them. So I guess we can just put them in a non-grouping capture group. Oops. Yeah. So maybe that is what we want to do. Okay. So this is going to be or BB. I mean. This is just a lot of unnecessary parentheses. So let's say def. Okay, and we can say def equals def if def dot length is greater than 1. Def. That's more reasonable. Okay. We still have this useless outer def. I mean, do we need these capture groups at all? A or B, A or B. Yeah, we do. We do. Okay. Well, you know what? This is some extra capture groups, but these are process rules, so that's good. And then at the end of the day, each one of these we can use to construct a regex. Okay. So that's process rules. So now we're gonna want to regexify these rules, and if I can remember what the hell we're doing, then we want to match it against these. How many messages completely match rule 0? So rule 0, and is that's what we want, is how many completely match rule 0? Okay. So producing the answer 2. Okay. So process rules. I guess what we can do is we can, okay, so we can say this is the string. Oh, we only care about rule 0 though, right? Okay, is it still the same thing? Yeah, okay. We only care about rule 0. So let's just manually do this now. So, okay, process rules, don't need JSON stringify anymore. Okay. So process rules, we got our new rules. And we can say rules 0, the first rule. New regexp. So, okay, we're gonna grab that. Let's log that to see what we get. Do this regex dot test. So let's test this one. So the goal is to determine, okay, these match and the others don't. A, B. So everything starting with A, B matches. Okay, so let's assert these things here. Asserts r dot test. So that's not test, that's test, that's not test, and that's not test. No. Okay, so we failed. On line 116, so this one is matching. But it's saying that it should not. So why is that? That's really demoralizing. Because it worked for everything except this last one. Okay, so okay, completely AB match, but okay, so let's log. Oh, we are logging. Oh, our test. We want to log R. Okay, so A. So let's take this and we'll break it down as like a CoffeeScript regex. So we can remove that. So we got A followed by A or B followed by ABBA. So one of these, and then finally ends with a B. Are we not anchoring? Maybe we need to anchor. All right. I don't know if we need to anchor. Do we need to anchor? Let's find out. Anchor. $. There we go. So we're anchoring them to the end, and then we'll text sub in the first rule. So still no, and then this time on 112. So log R, oh, I guess we can't do that. Let's do that. Oh, so that worked. It was the anchor. Beautiful. Okay, yeah, because this starts with an A, ends in a B. Log R. This starts with an A, ends with a B, but this ends with a B. I don't know why that's not working, but you know what? It works with the anchors, so I'm cool with it. So let's make a function. Regexify, and we're gonna need rule, and that is going to do that, and then we can just, so really that's really all this is going to do. R equals justify rules okay, so we got that. So regexify process rules still work? No, something broke. False equals true. Rule. Okay. Yeah. Okay, cool. So we've got a rule, which is to regexify the string. And then what we want to do is we want to count valid. And that's going to take in, let's take in our rules and our data. And we are going to regexify the first rule, and then we want to say data dot select line, and we're going to say r dot test line. So this is going to give us a return value, or a return array, and then we can just call length on it. So let's see if that works. Count valid rules data. Count valid rules data. And of course we could just split that up like that. So count valid data select is not a function. So array select, what's data? I thought data was data. Log data. So data is an array. Was it filter? Let's filter not test. Can't keep track of what R is not defined. On 116. Oh yeah. So actually we want to, yeah, we want to keep regexify down here for the assertions. Okay. And let's log count valid. So this should be 3. Oh no. Data filter. Maybe filter is positive. Yeah, let's look that up. JavaScript array filter. See, filter to me sounds like we're removing things. Creates a new array with all elements that pass the implemented. Yeah, so this is like select in other languages. Okay. This line kind of bothers me. I mean, this line's kind of doing a lot too, but I mean, what we could do is R and then the rest equals like that, and that's not undefined is not a function. Why is that on 104? Oh yeah, regexify. No, it's process rules. So this is rules and then regexify R equals, whoops, like that. Yeah, is that better? I don't know. I don't know, because then what we could do here is we could say length equals data filter line and then length like that. It's longer. I don't know if it's necessarily better. Let's leave it as for now. Okay, let's see if this even works. So these are our assertions. This is logging, and then we want to assert finally that 2 rules pass. Assert whoop, 2 is can valid rules data. Okay, and that of course that could be parse input. So this is what we're going to do down here. We're going to run, we're going to log can't valid parse input acquire input and run it. Bam, blows up. Can I find, oh right, I guess we should have the input for it to import. New file, input, copy. Oh yeah, module.exports equals cool. Evaluate 210. So it gives us this number 210. That's how many it thinks are valid. So let's try it. That's the right answer. Okay, we're 1 gold star closer to saving our vacation. Cool. And it's only been like an hour. That's pretty good the last couple days. Continue to part 2. Okay, so let's see how bad part 2 is. As you look over the list of messages, you realize your matching rules aren't quite right. To fix them, completely replace rules 8, 42, and 11 with the following. No, that's not good because they're self-referential. Now, rules do contain loops, and the list of messages they could hypothetically match is infinite. You'll need to determine how these changes affect which messages are valid. Now, the rules do contain loops, and the list of messages they could hypothetically match is infinite. So you'll need to determine how these changes affect which messages. Fortunately, many of the rules are unaffected by this change. It might help to start by looking at which rules always match the same set of values and how those rules, especially rules 42 and 31, are used by the new versions. Remember, you only need to handle the rules you have. Building a solution that could handle any hypothetical combination of rules would be significantly more difficult. So you only need to handle the rules you have. So I guess, so for example, okay, without updating rules in 8 and 11, these rules only match 3 messages. However, after updating, a total of 12 messages match. After updating 8 and 11. So rule 0, which is the one that we care about. So they're basically saying, I guess what they're saying is don't pre-process the rules. Get the rules, process the rules and evaluate them as you need to. So that's part of, I guess, what they're saying. But this does want 8 and 11. And then what are 8 and 11? 8 is 42. And 8 becomes 42 or 42 and 8, which is infinite. So that makes no sense. This rule makes no sense. So what the hell, man? And then 42, 31. Oh, that's not 42 or 8. That's 42 or 42 and 42. Or 42 and yeah, that would become infinite. The small changes, big impact. Now rules do contain loops. They do, because they contain themselves. And the list of messages they could hypothetically match is infinite. you'll need to determine how these changes affect which messages are valid. So what does this mean? This means that, what is this in a regular expression? Because this is how we've been solving it. So this is probably a good example of where people fell over in the past. So this would be 42 or 42 plus. So if you see, maybe if you see a self, so if you see a reference to yourself in a pattern, in a part of a pattern, does that just mean that you could repeat yourself forever? But in this case, 11, you get 42 plus. So that could be 42, 31, then followed by 31. Is this a back reference? Let's look it up. Regex back reference. Match the back references to match the same text again. Oh, this site. I think this site is really great, but it's also extremely difficult to understand. But maybe that's regex's, baby. Okay, back references. Match the same text previously matched by a capturing group. So suppose you want to match a pair of opening and closing HTML tags. Matches the exact same text that was matched by the first capturing group. So what we could do is we could in the pipes, we could have those capturing groups. We could make each section that isn't in a pipe, we could wrap those in a capture group, and then we could use a reference to itself. We could replace that with a back reference. Maybe. And can you do back reference in JavaScript, regex? Apparently you can. Okay. Back references and pattern, NNK. Okay. Back reference by number, and oh, interesting. A group can be referenced in the pattern using n, where n is the group number. Cool. That's neat. I mean, we won't be able to do it the way we're doing it, but and then K is back reference by name. See the pattern found in opening quote. I mean, can we back reference not by not by name or number? Can we do it by, no, I guess we need to do it by, so let's see, applies the regex to the string, backtracking into capture group, repetition in back reference. As I mentioned above, regex extension does not permanently substitute back references. Okay. Parentheses and back references cannot be used inside character classes. Okay, I mean, so I feel like this is, get rid of that now. Get rid of that. I feel like a back reference is almost is almost the right answer, but maybe it's not. So in this case, we could wrap that 42 or 42 back reference, but and then when this gets subbed into a larger one, that back reference by number wouldn't be correct. So we could back reference by name. We could do that. Yeah, this is all back reference by number or by name. Let's see what they're saying. Okay, so string in place regex function match. What is it saying? This would be used to replace test with test, and this is, I don't think this is actually back references. There we go. JavaScript regex back referencing. Let's say this here. What is okay, please stop. There we go. Websites that do that, please don't do that anymore, just generally speaking. Yeah, they're back referencing by number, and the actual pattern is denoted by a number. And then you can also do groups of subgroups. Where do we, I guess back referencing by name is probably what we want to do, and then we can name it based on the number of the loop. So where's the back reference by name section? K name. So we need to named, give them names. So, okay, well, what we can do is we can give them a name. So we can give, you can't back reference while you're inside a thing though. Yeah, and this back reference is only going to work. It's not going to work for this other case where it's like 11 is going to back reference what? Like itself, I guess. Yeah, that's confusing. So the rules do contain loops, and this contains contains both of these loops. So like, I guess what we could maybe we, but it could go on forever. Okay, but you know what? It doesn't need to go on forever. It only needs to go on until the string is no longer matched, or until the what's the longest string? Because what we could do is we could limit the number of substitutions to just bigger than the longest string. So longest string is like, doesn't have to be exact, is 88 characters. So I mean maybe a bit longer. So we could cap the loops. We could cap the self substitutions at like 88 or at like 200 or something, or 150, and then we would be guaranteed to have a regex that is long enough to match it. Yeah, I don't like that, but I mean, like, it's not, it could be worse. Okay, so where are we doing? This is in process rule. So what we're doing here is we are mapping each symbol, and it's going to go into an infinite loop unless we stop the infinite loop. So what we can do is we can pass in a number to process rule, and this can be so we've got our key. So when key is key, what we can do is we can pass in so we're going to pass in an iteration is 0. Okay, so if sim is key, we're going to do sim iter plus 1. Otherwise, I guess what we can do is we can just do the same thing. We can just do sim and then iter plus 1 if sim is key, then iter plus 1, else 0. I guess we can do and iter plus 1. Okay, and then what we'll do up here is we'll return cache key. So this would return false. So this is weird. Maybe so this is gonna be annoying because I guess we'll return an empty string if iter is greater than 100. And let's see if this gives us output. No. Okay. Okay, and then oops. Okay. So what does this do? Assertion false equals true. Let's see. Oh yeah, because this is now changing these rules. So what are? Oh shit! This is file 1 still. Okay, let's grab this and put it in file 2. 2.lit coffee. So this is like a shitty cheating version of of what we should actually be doing, probably. Though I don't know a better way to do this. Come on, get out of here. Okay, come on, back. Yeah, back. Yeah, still work? Yeah, it does. Beautiful. Okay, that's where we were. So, okay, let's grab the text from part 2 and we'll put it in here. Okay, cool. And we'll see. Playing. Okay, so for example, this is our input. Okay. Okay, and then yeah, man. Okay, so this is our input. And what are they saying here? It's part 2. So 8 and 11. So do we have to do the substitution for 8 and 11? We do have to do the substitution without updating. These rules only match 3. So these should match 3. Assert 3 is can't valid. Nope, doesn't. Assertion false equals true. So let's see what are the rules at this point. Let's log rules. Okay. Yeah, so that's before the substitution. I guess what we can do is we can just log can't valid. 0. None of them are valid. Well, okay then. Mind you, we've changed process rule. Let's put it back to regular process rule and see if maybe we've just completely screwed up process rule. Okay. Yeah. Okay. Cool. So yeah. So we screwed up process rule somehow. So return if iter is greater than 100. Oh, this, it's this if someone's key thing. Yeah, I screwed that up. Okay, so process rule, goodbye. And then hello, new process rule. So iter sim is key and 1. Let's try that. Okay, cool. So it's kind of shitty. It's kind of hard to read. So if sim is key, what we should really be doing is we should say, we should just do it on its own line. And then iter plus 1, else we should process rule with nothing like that. Okay, much easier to read. Okay, and then we'll add this. We need to add a loop, so a loop counter, or an iteration counter. Iteration counter stops. So we haven't actually even tested this with repeating rules. So what we want to do is we want to replace the rules now. So rules dot replace, or rules, what is it, 8? Where are you? So if we replace the rules, becomes that. Okay, actually I guess we can just so it's gonna be replacements or substitutions. So what do we got here? Rules. So we can take parse rules out. Parse rules equals, and we're going to take in rule defs, and rule defs is going to be just a giant text block, and then we're going to pass back rules. So parse rules, rules defs. Okay, split it on, map on it, wrap it in a bow. Okay, and then so now that we have that, we can just call parse rule, rule defs, parse rules, rule defs, and that can be rules. Parse rules, rules defs, and then rules, like that. And then rules. Will it still work? Nope, something broke. Rules is not a function. There you go. Still works beautifully. Okay, cool. Okay, so parse input, parse rules. In fact, we don't even need to do that. We can, yeah, whatever. I don't care. That's fine. We can have an extra variable. I can afford it. I'm wealthy. I'm wealthy of memory. Okay, so now we have process rules. We have parse rules, so we can parse rules subs. So we can say subs is parse rules subs. Subs equals parse rules subs. Eat fresh. Or we don't even need to do that. We can just say for key val of parse rules subs. We can say rules key equals val. So we can update our rules, and then we'll log the rules with the substitutions. Cool, and it's still logging rules, and it's still asserting that count valid for input is 3. That's cool. 8, yeah, all right. Is it still gonna assert that these are true, or are these gonna fail? So that's interesting. R is not defined. Oh yeah. Ooh, it went on for a long time and then freaked out on line 154. So it didn't like this one. That's interesting. So that's without updating rules in 8 and 11. Okay. However, I guess this is our new oh, these inputs are no longer valid. Okay. 3 messages, and after a total of 12 messages map. So okay, so count log valid 3. Well, that's not correct, because at this point it should be 11 match, right? Without updating rules 8 and 11, these rules only match 3 messages. However, after updating, a total of 12 messages match. So this is not good, because we've updated rules and it's still matching apparently 3. Oh no, because that's parse input. Okay, so we need another method that's like apply subs equals, and that's going to take subs, which is text. Okay, and that's, I guess what we can do is we can say that the subs are an array, so we'll have to parse rule the sub. So apply subs equals that, apply subs, and then we're going to take rules data. Cool. And what is this going to do? It's going to do exactly this. It's going to do that. Rules and data. Data is an array. Okay, so return for a key value of subs, and then we're going to return rules and data. Let's do that. So that way we can just sub it in. Okay, so apply subs. Okay, so count valid, and we're going to apply some subs and then put that in. So that freaked out. Why is that? Subs is not a function. Oh, comma. Okay, so 12. Okay, nice. Parse rules subs. So we can actually just put that in like that. Okay, so we don't need to log those rules. So we don't need this anymore. So log count valid without applying the subs. That should give us 3, and then we should get 12 eventually. Okay, 3 is, and 12 is, and these are not logs, they're assert. And then what we really want to do is we want to, when we're processing the rules, what we want to know is we want to know what this number should be. And I looked at the data and I saw that it should be a high number, like over 88, or so I just made it over 100. But like that's anytime you have this like fixed number in your code like this, where you're not just incrementing a thing, but you have a fixed number, you really should what is this? Receive calls or active cellular data. What the hell? Well, that's not good. Okay. I don't understand why my phone is now telling me it can't access the cellular data network. Let's power off and power on again. So anytime we have a number like this, what we should do is, if we can, it would be nice to be able to pass this in. And what we could do is, of course, where we're calling process rules, we have the defs and the cache. We could also pass in the rules, or the data rather, or the data length even. So where are we doing process rules? We're doing process rules in count valid. And so process rules. So data length, we could put data length in here and then pass it through to process rule and then check against it here. And data length, we'd have to look here in count valid. We would have to say data dot. We'd have to find the max length. We've mapped the length of each one and then just pull max out of it. The other thing we could do is, it's a common thing that whenever we write this kind of stuff, sometimes we want access to all the stuff. So I kind of make it a habit just to pass in rules and data, rules, data, like everywhere as the first two arguments, which is sometimes unnecessary, but in this case, it might be nice because like we're passing in rules, passing in data, passing in rules, passing in data, and then we'd have access to data length here. We could figure that out, or we could do it once here in process rules, and we could figure out what the repetition is. I'm going to leave it as 100 right now and just see if this works, because I'm curious if it works. But that's what we would probably want to do if we weren't being pieces of shit. Well, that log count valid, apply subs, parse rule subs. What are we logging stuff that I don't know about? Log count valid. Okay, so that's interesting. Did I just make a change in here? Oh yeah, I did. No, I didn't. Assert 3 is count valid. Let's see if that is true. Yes. Okay, and then we're gonna log count valid. This should give us the old number, 210, and then we want to count valid, apply subs. So why is it giving me, is this an error message? Invalid regular expression. Well, shit. Invalid regular expression. I knew it was too good to be true. That makes me sad. And why? Why is it invalid? It's invalid because it's too long? Maybe. Regular expression max length JavaScript. Doesn't have, I'm not finding a lot for the maximum length, maximum number of characters JavaScript. No, this is how to enforce the number max length. So why is this, why why is this an invalid regular expression? I guess because it's I guess what we could do is we could do that. We could do parse input, get a regex for the first rule, which is, what we're doing here. Let's log R. And then we'll log just a new line. Okay. So this is our first one. Then this is our second our second count valid. This is definitely repeating a lot. Jesus, okay. Whoops. What I actually want to find is I want to find out where this broke. Okay, syntax error. So it's a very big regular expression. It's this one. Is it just like, is this failing in Node? Regex tester. Let's try it. Online regex tester. We want just JavaScript flavor. Flavor JavaScript. Okay. Good luck, browser. I can hear the fan turning on. The fan, just pasting this into the browser has caused my browser to eat all my CPU probably. Is it this guy? Yeah, here he goes. He's warming up. Come on. I mean, the page is unresponsive. I can't even open the dev console. All right. You're gone. Aw, snap. So let's open that up. Okay, so let's load sponsor data. Oh no. I'm so sorry that you can't show me your ads. Yeah, this is gonna be cranky. So Node gave us a pretty quick thing that this was just not correct. So I guess one thing that we could do is we could try to get a sense for whether or not this is valid. So let's make a new file. Let's count those. 1 out of 11111 matches. Oh, that's interesting. And 1 out of 11111 matches. Okay. There's 11,312 A's, 13,130 B's, and 8888 pipes. So it's likely that it's just too big, that Node is freaking out. Let's try with half the number of iterations, and see if this works. So it's just failing. It's failing on 151. So let's try, that's with 50, or no, whoops, that's with 2. Let's try with 50. 50 still breaks. Let's try 30. 30. Doing some. 422. Oh, hey, look, it gave us output. 422. So we just zoned in on a regex that was like long enough to make the second assertion pass. But then it could just be giving us not the right answer. So let's try 30. Let's try 30 and see if, oh God, I forgot about this guy. No, monitor, there you go. Please die. There you go. You've done a great service, tab. Now it is time to rest. Okay, we didn't use back references at all. We just made an error-prone and shitty regex. So was it 420? Was that what it was? Is it still my paste buffer? 422. Thank God. Okay. That's the right answer. That's cool. I feel bad about it because, and I'm gonna leave a big caveat here. Like anyone looking at this in the future, which will be no one, but this was an arbitrary limit that worked. I'm just going to leave a note about why the limit was chosen. Originally, it was going to, or it was planned to be the max length of a possible input. So I guess that's one thing we could do, but you know, even then, no, it was planned, but Node rejected the regex due to length. So I kept making it smaller until it worked, until it passed assertions, passed the example assertions, and produced a number, an answer. The answer was accepted, but this is extremely buggy and should not be considered reliable. So there we go. Lots of caveats here. Dragons. So I like to put a reference to dragons, like here be dragons, kind of like you're going off the edge of the map. Like don't pay special attention here. Pay special attention here. So, and you know what we could do, because that's actually interesting, because this is literate CoffeeScript. We could actually oh no, there we go. Come on, give me those back. There we go. What we could actually do is we could leave this as an inline hint, like that. Actually, we have to probably do it. Can we do that? Yes. Okay. So the cool thing here is if you look at this and how it renders. So you're going down your code, defs, and then dragons. Here's this warning area. Is that really how you spell dragons? I guess it is. So you can actually just put in this CoffeeScript bit right here, or this markup, this markdown thing. That's one of the things I've grown to like about literate CoffeeScript, is that it's good when you need to add big documentation. But you know what I am going to do is I'm going to take this out of the code block. I'm going to put it here. Dragons 30 is an arbitrary limit. That worked. Happened to work. Originally it's planned to be the length of a possible one, but checks due to the length. Okay. Cool. So let's see how that looks. Okay. Part 2. Defs. Dragons. Okay. 30 is an arbitrary limit. Okay. Good. Tests run. Cool. Let's make sure that it still runs. Build should eventually spit out 422 after a couple minutes. 422. There you go. Beautiful. You know what? I'm okay with that. I'm gonna call it. We left if you can't make the code good, leave a warning. Day 2. That's a terrible lesson to take away. But you know, sometimes you got to do what you got to do. Yeah, I mean, and I'm hungry, and I got a dog to take out, and this is gonna get us moving on our holiday. Day 19. Okay. Cool. So, I mean, that's that. That's day 19. I'm gonna update the README and then push it up. It could have been worse, but I'm okay with how it went actually. So let's go 19, and then this is the YouTube video. So skip 18, video that. Okay, same list. And what's it called? It's called Monster Messages. He sent the message. He sent the monster message. Whoops. Yeah, man. Cool. Add day 19 to README. Add day 19 to README. Cool. All right. Well, thanks for sticking around. Anyone who stuck around, if anyone actually watches these and sticks around, I will see you tomorrow for day 20. I like how this is filling in. This is looking nicer. Oh, there's a Loch Ness Monster. That's so good. Okay, cool. So yeah, until tomorrow, keep your stick on the ice. Later.